Let's dive right into this rapid micro explainer. Today, we're locking down two absolutely essential SI-derived units for plane and solid angles, the radian and the steradian.
But before we get into the math, think about this for a second. How exactly can we measure an angle just by using the length of an arc? And what happens when we level up and try to measure a solid angle in full 3 dimensions?
Okay, so let's start flat in 2D with the radian. This is our fundamental unit for measuring a plane angle. And the definition is actually really elegant. A single radian is just the angle formed right at the center of a circle by an arc whose length is exactly equal to the circle's radius.
You can really see that elegance when you visualize it. Notice how that one perfect radian only happens when the outer arc length, which we call S, perfectly matches the length of the radius, R. It's a strict 1-to-1 ratio. And that visual directly gives us our crucial formula. Theta equals S over R. When that arc length equals the radius, boom, theta is exactly 1 radian. And because of this neat little relationship, if you go all the way around, one complete circular revolution, you get exactly 2 pi radians.
All right, let's step it up to 3 dimensions. We're upgrading from flat circles to spheres, and for that, we need the steradian to measure solid angles. So 1 steradian is the solid angle formed at the center of a sphere, but this time it's formed by a surface area that's equal to the square of the sphere's radius.
Picturing this in 3D makes it click instantly. Think of a 3D shape projecting outward from the exact center of a sphere. It forms 1 steradian when it perfectly covers a patch of surface area equal to the radius squared.
So, applying our 3D formula, omega equals area over radius squared, we get another really cool rule. The total solid angles surrounding any single point in space, it's exactly 4 pi steradians.
So, to quickly bring it all together and summarize those core differences, just remember that the radian measures 2D plane angles inside circles, while the steradian measures 3D solid angles inside spheres, flat versus solid. Okay, let's test your active recall with a quick question. Based on what we just covered, which of these statements correctly describes 1 steradian? Go ahead, take a few seconds to lock in your answer.
If you guessed B, you hit the nail on the head. 1 steradian is the SI unit of solid angle, and it's always directly tied to an area equal to the radius squared. Keep this fundamental distinction locked in for your exams, and you'll be absolutely golden. Thanks for joining this quick explainer.